Today we are going to learn about creating complex calculations in Pandas Pivot Tables. You will gain the skills to perform intricate data manipulations, enabling deeper insights and enhanced data analysis capabilities.
Welcome to this video on creating complex calculations in Pandas Pivot Tables. In the next 15 minutes, we will explore how to perform sophisticated calculations within Pandas Pivot Tables, a crucial skill for detailed data analysis and reporting. By the end of this video, you will be able to implement multi-level calculations and use custom functions to enhance your data analysis capabilities. We will cover an overview of calculated fields, basic arithmetic operations, aggregate functions for data summarization, creating custom Python functions for calculations, combining multiple fields for advanced calculations, handling date and time calculations, and utilizing GroupB for hierarchical calculations. We will also delve into a case study that applies these calculations in real-world business scenarios. Let's get started.
Calculated fields in Pandas Pivot Tables allow us to perform calculations on other fields within the table. These fields play a crucial role in data manipulation and enable users to derive new insights from existing datasets. In Pandas, calculated fields can be added directly within the pivot table by defining them as a new column. This involves using standard Python operations or functions to perform calculations on existing data. Common use cases for calculated fields include calculating percentages, differences, and ratios. For instance, if you have sales data, you can create a calculated field to determine the profit margin by dividing the profit by sales and multiplying by 100. This calculated field will then be available as part of your pivot table for further analysis. The benefits of using calculated fields are manifold. They not only streamline the analysis process but also facilitate quick and dynamic calculations without altering the original dataset. Basic arithmetic operations such as addition, subtraction, multiplication, and division form the foundation of complex data analysis in Pandas Pivot Tables. To perform these operations, Pandas provides intuitive syntax that allows users to manipulate data columns directly. For example, if you wish to calculate the total revenue, you can simply multiply the quantity column by the price column within the pivot table. These operations can be embedded within the pivot table definition or applied as new columns after creating the pivot table. Practical examples include calculating total expenses, net profit, or even comparing year-over-year performance by subtracting last year's data from the current year. Such operations contribute significantly to data insights by allowing analysts to quickly assess financial performance, identify trends, and make data-driven decisions.
Aggregate functions are pivotal for summarizing data within Pandas Pivot Tables. These functions help in condensing large datasets into meaningful summaries. Commonly used aggregate functions include sum, mean, count, min, and max. To apply an aggregate function in a Pandas Pivot Table, you can specify it in the func parameter when creating the pivot table. For instance, if you want to see the total sales across different regions, you would use the sum function on the sales column. Similarly, to find the average sales, you would use the mean function. The advantages of using aggregate functions are numerous. They provide a clear and concise overview of data, highlight key metrics, and facilitate easier comparison across different categories or time periods. Practical applications of aggregate functions include financial reporting, inventory management, and sales analysis, where they help in tracking performance, identifying bottlenecks, and optimizing resource allocation. Sometimes, built-in operations and functions might not suffice for specific analytical needs, necessitating the creation of custom Python functions. These custom functions can be defined to perform complex calculations tailored to specific requirements. To create a custom function, you define it using the def keyword in Python, followed by the function logic. Once defined, this function can be applied to the data columns in your pivot table. For instance, if you need to calculate a weighted average, you can define a function to multiply each value by its weight, sum the results, and divide by the total weight. Embedding custom functions in Pandas Pivot Tables enhances analytical capabilities by allowing for more tailored and sophisticated data manipulations. Examples of custom calculations include adjusted gross margins, complex financial ratios, or even custom scoring algorithms for predictive analytics. By leveraging custom functions, analysts can extract more nuanced insights and make informed decisions based on their unique data context.
Combining multiple fields in Pandas Pivot Tables allows for advanced calculations that can reveal deeper insights from data. This involves using multiple columns or data points to derive new metrics or indicators. Techniques for combining fields include using expressions that incorporate multiple columns, such as calculating a composite index or a performance ratio. An example of advanced field combinations is the calculation of a customer lifetime value, CLV, by combining average purchase value, purchase frequency, and customer lifespan. Such calculations provide a holistic view of customer value and can inform marketing strategies. The benefits of multi-field analysis are significant. They enable a more comprehensive understanding of data relationships, facilitate cross-functional insights, and support strategic decision-making. By combining fields, analysts can uncover hidden patterns, optimize operations, and drive business growth. Date and time calculations are integral to temporal data analysis and can provide valuable insights into trends and patterns over time. Pandas offers robust tools for managing date and time data, including functions for parsing dates, calculating differences, and extracting specific date components like year, month, or day. Common date/time operations in Pandas pivot tables include calculating the duration between two events, determining the day of the week, or aggregating data by specific time intervals, such as weekly or monthly. These operations are crucial for time series analysis, enabling analysts to track changes over time, forecast future trends, and identify seasonal patterns. Applications of date/time calculations are widespread, ranging from analyzing sales trends, monitoring website traffic, to managing project timelines. By enhancing temporal insights, analysts can optimize resource allocation, improve scheduling, and drive timely decision-making. The Group B function in Pandas is a powerful tool for performing hierarchical calculations. It allows users to split data into groups based on one or more keys, perform computations on these groups, and combine the results. The syntax for using Group B involves specifying the columns to group by, followed by an aggregate function to apply to each group. For example, to calculate the total sales per region and product category, you would group the data by region and category and then use the sum function on the sales column. Real-world examples of Group B include analyzing departmental performance within an organization, segmenting customer data for targeted marketing, or tracking inventory levels across different warehouses. The benefits of hierarchical insights are substantial. They allow for granular data analysis, facilitate comparisons across different segments, and help in identifying key drivers of performance. By leveraging Group B, analysts can gain a deeper understanding of complex datasets and make informed strategic decisions.
In this case study, we will apply the skills learned to a real-world business scenario. Imagine a retail company looking to optimize its inventory management. By using Pandas pivot tables, the company can perform complex calculations to determine optimal stock levels, identify high-performing products, and predict future demand. We begin by importing the sales and inventory data into Pandas and creating a pivot table that summarizes sales by product and region. Next, we calculate the average sales per product using aggregate functions and identify trends using date/time calculations. By applying custom functions, we calculate a replenishment index for each product based on sales velocity and lead time. The results reveal which products require immediate restocking and which can be phased out, providing valuable insights into inventory optimization. The impact on business strategy is significant. The company can reduce holding costs, prevent stockouts, and improve customer satisfaction. This case study demonstrates the practical application of complex calculations in driving business efficiency and growth. As we conclude this tutorial on creating complex calculations in Pandas pivot tables, let's recap the key learning points. We explored the importance of complex calculations in data analysis, learned how to implement basic arithmetic operations, use aggregate functions, create custom Python functions, and combine multiple fields for advanced calculations. We also delved into date and time calculations, utilized Group B for hierarchical analysis, and examined a business case study. These skills are essential for extracting deeper insights from datasets and making informed decisions. I encourage you to practice these skills with your datasets and explore additional resources for further learning. Thank you for joining this session, and I hope you found it informative and engaging. Happy analyzing!